Okay, in this video I'm going to show you the solution to problem 5.2 in Stallings. And it says find the optimum wavelength and frequency for a half-wave dipole antenna of length 10 meters. Okay, so here's the picture of a half-wave dipole antenna. And what we're going to do is we're going to set the length of that antenna equal to half of a wavelength. And therefore the wavelength is 20 meters. And to calculate the frequency, we simply plug in here and we get 15 megahertz. That's an easy problem. I'll show you problem 3. Also, although it wasn't assigned, ocean penetration of electromagnetic waves increases with the wavelength. That is, at lower frequencies. That is, it increases as the frequency is lowered. Suppose a submarine system has proposed to operate at a frequency of 30 hertz. What would the length of a half-wave antenna be? Oh boy, that's a low frequency, and if we do the calculation, what we're going to find is that the wavelength is 10 million meters, and that the half-wave length antenna is 5,000 kilometers. In other words, it's infeasible to make a half-wave antenna that operates at 30 hertz. That's a simple little calculation. Problem 4 was assigned, and in this one he's talking about the human voices frequencies centered at 300 hertz, and asking what is the length of a half-wave antenna at 300 hertz. Well, like the last problem, when you have these low frequencies, you have these incredibly long wavelengths, 500 kilometers for this one. And he in part B, so the half-wave antenna size would be 500 kilometers big. For part B says we want to use a 1 meter long half-wave antenna. What should the carrier frequency be? And the carrier frequency we calculate very simply is 150 megahertz here. Okay, that's an easy problem as well. So that's problems 2 and 4 from your homework assignment.